Hi everybody. So in this video, I'm going to show you how to translate a curve using function notation. So we have this parabola here, and we can call this y equals f of x. And I want to use this to show you how we can represent each of these different translations using vector notation. So if we have y equals f of x plus a, then this would translate every point on this curve vertically upwards by a units. So using vector notation, this would be 0 in the horizontal, but a units in the vertical. Similarly, if we had f of x minus a, well, this would move the curve down by a units. And if you notice that the two curves remain parallel, it's just the position of a curve that changes. In vector notation, this would be 0 and minus a in the vertical. And when the a is in the brackets, if you notice here that this is out of the brackets, so we apply this translation to the entire function, well, this is when it's in the brackets. So now we're applying the translation to the x values. So f of x plus a moves the curve a units to the left. The reason why it moves to the left is because we can see, if we're looking at this point and we want to get back to the original, then we have to add on these two. And this addition is why we have this positive a. In vector notation, this will be negative a for the horizontal and 0 for the vertical. And then when we have f of x minus a, and again this is in the brackets, now we're moving the curve to the right by a units. So if we want to go from this point to this point, we need to take away the 2 units, which is why this is a negative. So in vector notation, this would be a in the horizontal and 0 in the vertical. So now we're going to use each of these vectors to translate the functions in our example. If we have y equals f of x plus 2, well this 2 is outside the brackets, so we're applying the translation to the entire function. So this would be 0 in the horizontal, but 2 in the vertical. So we have our function, and we're moving it 2 units vertically upwards. And for question B, if we've got y equals f of x minus 1, and the negative 1 is in the brackets, we're going to translate the x values. So we'll use this vector, where we'll have 1 in the horizontal and 0 in the vertical. So we're moving the blue curve 1 unit to the right. And then for question C, we've got f of x minus 2. We can see this 2 is outside the brackets, so we're translating the entire function. So we'll use this vector, which will give us a translation of 0 and negative 2. So we have our function, and we're moving it 2 units vertically downwards. Okay, let's look at our next example. Okay, so in this example, we've been asked to translate this cubic. We have for 4 points, this point, this one, here, and here. And we've been asked to translate it to these 3 functions. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we have f of x plus 3, and this 3 is outside the brackets, so we're going to use this vector. So we'll have 0 in the horizontal, but 3 going vertically upwards. So we'll take our function and we'll move it 3 units vertically upwards to this point. So then you can see that every y value has increased by 3. It was at negative 4 on the y, now it's at negative 1, from the 1 to the 4, negative 3 to 0, and then from a 0 to positive 3. Okay? For question B, f of x minus 3, and this is inside the brackets, so we're going to use this vector, which will be 3 horizontally to the right and 0 in the vertical. So we'll take our function and we'll move every x value to the right by 3 units. So you can see in this point at -4 has been moved to -1 in the x. The -1 point has been moved to +2. When x equals 3, we've got x equals 6. And when x equals 6, we've got the 9. And then for part C, we've got f of x plus 1 inside the brackets, and then -2 on the outside. So if we look at x plus 1 to begin with, well, this will involve this vector, where we've got -a, and the a value is the 1. So this will be -1 horizontally, and then the -2 on the outside would involve this one. So this will be -2 vertically. So we've got our function. We'll move it 1 unit to the left, and then we'll move it 2 units vertically downwards. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.